Hey everyone, good to be here. I'm Danny Zuckerman, one of the founders of 3Bucks and Ceramic, here with Zach Berland, who's going to do a workshop today to kick you guys off for the hackathon. Before we do that, just going to give a quick intro to what we're building at Ceramic, especially because many of you may be familiar with the data management and profiles products we built at 3Bucks, but Ceramic is what we're going to talk about today, and really what we think can be exciting for your hacks over the next month. So I'll keep this pretty quick, so most of the time can be on the actual technical workshop, which will be more useful. But Ceramic is a data web for open applications. So if databases are for private and more specific information, Ceramic Data Web is for open, verifiable information that's used between applications. And so building with it, we can talk about a few different layers today quite quickly. So Ceramic itself kind of provides a connected metadata layer for blockchain applications, blockchains, and Web3 generally. So this verifiable information network is a great place to basically store content you want to use across chains, but then also metadata about things like keys and assets. And by putting metadata on Ceramic, which is chain agnostic, you're able to use that information across these different web networks and also describe information that's stored on various blockchains or servers or other networks. So kind of common metadata layer for Web3. It lets users bring their data across ecosystems, and developers build on a common set of information and data without starting from zero, each new application, each new network. The first really big use case on Ceramic is identity. IDX is the standard on Ceramic for user-centric data sets. And basically what lets developers create public definitions about information being saved with users. Each user creates their own reference for each definition, basically a pointer to where that information is kept on Ceramic or elsewhere. And all of those can be either public or private. So a lot of flexibility in the types of information that can be saved with users. And this IDX really provides this single place to route to different user information you might want to use as a developer, and also a really clean and nice and flexible format to store information about your users in a very Web3 compatible and, again, cross-blockchain way. And right now, Ceramic's on DevNet, kind of a beta stage. There's an implementation in TypeScript, but I will let Zach talk a bit more about that. So let's just go straight to this so we save time for the demo. I'll just leave this up for a minute. After this workshop, if you want to find us or find out more about Ceramic, come find us on Discord, ask any questions you have. We'd love to hear how your building experience is going. Love to answer any questions. We're on Twitter, follow us there. And on GitHub, and then I guess not on here, is our website, ceramic.network, which has all these links too. Zach, I will pass it over to you.
Yep, thanks, Danny. So I'll share my screen. All right. Yeah, so if you're looking to build with Ceramic, as Danny was saying, a core part of the Ceramic is these things called documents. And let's see. And so since it's early for Ceramic. We don't have a lot of the higher level abstractions yet. This is going to go pretty deep into sharing what it looks like at a lower level, what kind of pieces make up these documents, and how you can start to, build these, build things on top of them, build these kind of abstractions. We want to build with everyone so that we do, take into consideration what we need to work with other networks, work with other chains, etc. But a good place to start if you understand what makes up Ceramic is with the specification here. So I'll do a quick look through. There's two main things that are important. So the Ceramic docs, like I said, were built on IPFS and IPLD. So when you look at a document, you see this JSON object, but the underlying structure of that is actually a log that's made up of all these immutable records. So this is a DAG, and this is an IPLD. So if you want to make an update, you have this chain. You just reference your last update, and you build updates on top of that. So it's kind of cool. You end up with this immutable structure on top of, you end up with this mutable structure on top of this immutable log. The basic structure in Ceramic is that we have these anchor records pointing to signatures. Signatures are the updates, and then anchors are where we anchor these records in chains. You get this proof that this update was done at this time. So every time you make an update, you are then making an anchor record and sharing that. Each document starts with a Genesis record. That becomes the document ID in Ceramic. So like Ceramic docs basically have these identifiers you'll see here. If I wanted to resolve someone else's Ceramic doc, I would just share this in the Ceramic protocol, and then I'd be able to resolve it. With another part. So let's see. So you see most of it when I go through an actual code example. We'll step through basically what's like, we have all definitions here, but you can see them more concretely once I step through the code. So we have what it looks like for the Genesis record, the updates, how they're signed, etc. One last interesting thing right here is, like I said, anchor records. After every update, you're going to anchor them in some anchoring service. These look like this. You create a Merkle tree. You can collect a bunch of updates together, then publish this Merkle root in your document. This could like point to a bunch of different updates. Anyone could resolve this path by knowing the Merkle proof with the path and the root hash. Okay, so I'll step into the code now. Let's see. So I have this web page loaded. I already loaded a bunch of dependencies that you need in some of our core libraries. So one of the main libraries we have right now is Ceramic, so I'll load that here. This is the main library you would use to just create documents, update documents, and have all those main interactions. So a good place to start is we can create a document to do, let's see. And this is just ceramic.create document. I'm going to give it a type. There we go. And I already have this object on the window that I can load in. So I'm going to create a document with this JSON object here, and we'll see that in a moment. So I create it. All right, now we have the doc object. So this is the interface for a doc, and it has these properties that we can access on this document. So like I said, the actual doc representation is here. So I wrote this JSON document now. And yeah, this is like the high level representation of what you ultimately get. This is the abstraction you get by using this document interface here. But like I said, the actual underlying thing is these logs of updates. But we'll look at some other parts. We can see the doc ID, like I said before. So the ID for this is right here. We have another thing called head. So there we go. So like I said, since this underlying structure is a log, you actually want to know what the most recent update to that log is. And that's not going to be the same as the Ceramic ID, since this is the Genesis object. So if I want to know the most recent node, that would be this object right here. And basically how you map this to this is, so we share, when you connect to the Ceramic network, you're connecting to other peers. We're talking basically over libp2p in a pub sub room. So for example, if Danny wanted to get this document, he would say, hey, where's this document for this ID? And then other peers, for example, I would say, oh, hey, I have this most recent update. Here it is. And then they could resolve the entire log and verify that whole thing along the way. So we'll do some other interesting things. Like I said, you can make updates. So we got the doc now. We'll change it. So let's wait. So I had this other object on my window already. Change it. Now we should see the updated content. Yep. So now it's able to make an update, and when I made that update, that was published on the network, synced and verified. So now you can see the doc ID, of course, is still the same Genesis of the log. but now we have a different, so now we have a different head because we have a different update. So now this is going to point to the most recent update now. And like I said, these things are in IPLD and IPFS. So I already have an IPFS instance in the window. So I'm actually going to resolve this node through IPFS now instead. And we can basically walk through the underlying log structure for this document and see what that looks like. So we'll do dag.get. Let's see, we'll take that. And as we do this, we probably expect to get an, let's see, oops, dag. Yeah, so I resolved this node, this IPLD node through IPFS. And as expected, you can see we got an anchor record here. So like I said, this has a proof, and then it points to the previous node in the log. So since we're using the DAG interface right now, we can actually resolve the rest of that path and then walk down it. So I'll take, let's say, we can do previous. There we go. So I step now to the anchor record. You expect that it points to a signature record. And yep, that's what we have. So we have the signature record looks like this. We have a link, which points to the actual payload after, and we have the signature block on it. You could see earlier in the proof here that we had the pointer right here, linking to here. And we said this was a DAG Jose structure, so it's cool. You have these codecs to resolve these different data. DAG CBOR is what you often see in IPFS already. DAG Jose allows for these signed nodes, as well as eventually like encrypted links. So us and a few other teams are working on that and using that. We can continue to walk down the log and see. So after this, we should actually see the data update. So resolve the link. And there, now we finally see the data. So I said in the last update, I just added this property. This actual structure is a diff. So you don't write the whole JSON object in each node. You're just writing the diff each time. And as we compile it, as we put together that log and that document representation in the protocol, we're just putting all these diffs together, and then you get that final output. So you can see that here. That's the first update. If we keep going, we expect to see another anchor record again. There we go. It's another anchor record. This time we can take a quick look at what these proofs look like. So we'll do that. Yeah, and here's the proof. So basically this says, this would be usually a Merkle tree root right here, this root, so it's a hash. In this case, there's probably, and our anchor service is pushing these, so you don't need, any user doesn't have to publish this on chain themselves. They could push it to another service. Some service just has to include it in a Merkle tree or publish the hash itself on chain. I think right here, since there's only probably one update at our service right now, it's just, this is actually probably just a link to the last update and not the actual tree. You see here, you have to include the block number so we could look it up and verify it. Timestamp, we have this chain ID. So right now they're anchored on Ethereum, but you can actually anchor them on any blockchain. So you can have some other service that anchors them on Bitcoin or any other network, for example. The actual transactions included here. Again, the codecs, if I had this codec loaded right now, I could actually load this ETH transaction payload. I don't have it, but basically what you do is just you would look for this hash, to be included in this block number and verify that. And that's it. So since, like I said, the root, I think just points to the object. Yep, so it points just directly to my last update. Finally, we can look at, let's see. So we can do value dot yeah, so this record right here is another signed update. This is going to be a signed record of the Genesis node. So we'd expect that, and as you can see here, is that this link is the same as the ceramic ID. So now we basically step through the entire log. If I go back to here, I could have went one step further. And there you go. You see the original document that was created with the doc type, the original data payload, some of this extra metadata. So now we walked the entire log, and like I said, if you use this with the ceramic library, you just get this entire log in the JSON format. And ceramic for you basically verifies all these updates, verifies the signatures. Every one of these updates are signed, and then you get that. Let's see. So one cool thing, we have another library here called Identity Wallet. So I got that loaded on the window here. Identity Wallet is our library that manages this keychain for interacting with ceramic and our DIDs, our identities. So you can see here, actually the whole time I was using this Identity Wallet, I have an ID here. There we go. So this is basically my public identity, and this is using DIDs. So DIDs are these shared open standard that basically says you have an opaque identifier and they resolve to your key material. So with this, I could basically say, actually, let's see here. So so I actually have a resolver already, so we can see what that actually resolves to. Ceramic.context. Let's see, resolve. So I'm going to resolve that DID. Let's say wait. Okay. So as I said, these DIDs, the idea is like you don't need to go to any central service to resolve them. People can implement different protocols that resolve different ways as long as you implement the resolver and implement a way to get this document. So for ours, we resolve it here, and then we get this document. So you can see it has public keys, it has encryption and signing keys. The idea being, so you can see on this first document when I created it, I actually signed it with my DID. So I can do doc.owners. There we go. So you can see actually I was the document owner of this first document that I created. I was using my DID here. So basically the saying is that for all these records I signed with this public key in this did doc. So if anyone else wanted to verify my signature, they basically resolve my DID, get my public key, and then they can verify the signature on this doc on all the updates. And that's how I would verify someone else's doc. Like I said, anyone can implement this in any way. We have our own DIDs here specified by the 3, so that defines the protocol. So the cool thing is this identifier is actually a CAD and IPFS. So again, we can actually see what this looks like in IPFS. I'll do IPFS.dag.get doc.owners. Oh, actually, I'll just copy paste it. Okay, and then here's the object. So the nice thing about Influence is actually in IPFS is that we have a way to resolve it, and we have a way to say what the data is and build up that the document here. So if we look at the actual IPLD node, we'll see a few more things in here. So an interesting thing is not only is this just IPLD node with just data in it, it's actually a ceramic doc as well. So for 3 IDs, they're actually implemented on ceramic itself. So instead of resolving just this node, which means this is saying that this is the Genesis node in the block, we can actually resolve this through ceramic instead. So I'm going to create another doc. I just have the shorter function here. So I'm going to do a little this like this. I think I already have it here. So this is just saying I'm going to load ceramic / this CID right here, which is the ceramic IDs right now for doc IDs. So let's do that. doc1. Now let's look at the content. Okay. So we can see this now that my 3D is actually implemented as a ceramic doc. So the cool thing about this is not only now do I have this one immutable object for my DID, I actually have a way to make these updates. So that means I can do key rotations, I can add other keys, I can add other metadata, or any other things that are supported in a DID spec. So now I have, like I said, this mutable document on top of this immutable log, and I can make updates to it. So like you can see here, I actually already added some stuff that I didn't have when I originally created it. So you can see right here. Yeah, so I added this thing called IDX. Like I said, that's when it gets really interesting, is when you can start to add all these links to DIDs and resolve all this data. So we have another thing called, so you can see right here is that this link is actually another ceramic document. And this is called an identity index. So this is standard on ceramic as a way to link all this kind of data, whether it's other ceramic documents or anything else, to a DID. So we can take this. We have a library for interacting with this index as well. I have that loaded on the window, so you can see that right here. So we have IDX here. And this allows you to add stuff to this index. So now that we have like the basic document model established here, and show you how DIDs and how we sign all these document updates, we have one more abstraction up now, and that's this identity index. And in this identity index, we have the concept of definitions and schemas. So for any of these documents, you can actually specify a schema for them, and that's just part of the validation structure. That basically says, if I make a document with this schema, I expect to see these results here. I expect to see these properties. And then that document enforces that as part of validation. Also means when someone else resolves it, they know how to handle the data and load it into their apps, for example, or where to find it. So part of IDX, I already have a few schemas on the window here. So we can see them here. The cool thing is that these schemas themselves are also ceramic docs, so you could actually have versions. You can actually update a schema and then point to different versions of that schema. So one thing you might want to add, for example, to your IDX, to your DID, would be a profile. So anyone can get your name, image, or anything and see that across applications, for example. And then I want to know how to consume that. So I can take, so to see what that looks like, we can actually, again, just open this up. So we'll do another doc profile. There we go. So I'll load that as a document. We'll do doc profile.content. And there, now we can see that it says that any document that implements the schema, we expect to see these properties with these keys, with these values. There we go. So that's what that looks like. Now we'll open, so I have another one here called definition. So IDX is mostly made up of these things called definitions. We'll open that up to see what that looks like. So we do doc all right, so I'll load that ceramic doc for that definition. Whoops. Mistyped that. Oop. Okay, so now we have this doc def. There we go. So there's a schema for definition. So in this thing called identity index we're talking about before, identity index is just this mapping of definitions to references. And definitions are these things that allow you to, we'll open it up here so you can see. They basically allow you to attach all this information about a service, about a data store, basically allows you to add data sets and link in any protocols or anything else. So you can see here, I could basically say, I want to have a data set that implements this schema for this reference. And then this can resolve to any kind of service. So one example is if you're using if you want to do a profile, I would say I would create a definition that says that this reference is going to use this schema and implement this. It's going to say, in this case, that it's implemented on Ceramic itself. But you could actually point to any other kind of storage layer. So you could have stuff that says, you can find this in Textile, you could find this in this other DB layer. It could have other service information. So this could say, this data is stored in Filecoin somewhere. You have to set up these payment channels or any other kind of metadata. But basically, when someone wants to resolve this data set for me, they could say, they could come here, I could share this. They would know where to look it up, how to connect to it. It could even be something like a standard API, and it would just say like, the data is at this service and it implements this schema. And this is how you talk to it. So you can add all these things to IDX. And then anyone else who wants to resolve my DID can find any of these things. So we'll do, to show that, so I'll actually say I want to add some profile information to my Ceramic doc, to my IDX. I can use the IDX library, so I'll do I already got one here. No, let's say. Yep, so I have one here. So basically I can come to, let's see. Oh yeah, let's do const def profile. Here we go. So in IDX, I can create a definition. I might say I have some app. I want to implement the profile definition for that. And I want to follow the profile schema. And so without any other data, it's just going to say, it's a link to actually another Ceramic doc. So I'll create that. All right, so now I have that. You can see this definition itself is a Ceramic doc. Oop. And then now I can actually write stuff to this document defined by this definition. So I can go, I can do, let's see, IDX dot set, and I'll reference this definition. There we go, I'll set some content. Since I'm following the profile schema, I'm gonna set my name. Oops, there we go. Oh wait, let's see, IDX dot set. Yeah, I forgot to pass that as a string. So do that. All right. So now I said, now that I actually added data, that I actually created this new doc as another reference. So we can see that here. So now it basically says, now you can also get it. So I could do idx.get. I want to pass the same definition again. And there we go, it's going to return the data. And this is basically saying, I'm already authenticated, so it's saying through my own DID, I'm going to look up this definition, basically this definition in my IDX, and then it's going to find this reference, which is this doc, and it's going to load this data from it. So there you go. So I could also say if I wanted to pass someone else's DID, like if I want to resolve like Danny's profile, for example, I could actually just pass in the DID here. I don't have any other documents set up here, so I just pass my own. Not too interesting since it's the same effect, but basically I could say, here's Danny's DID. It's going to resolve it by looking into his identity index, then resolving this reference, and then resolving this data for it. There we go. And you can start to add all these schemas and these kind of references all into the identity index. There we go. So that's what we have for Ceramic so far. Like I said, everything's changing. Some of the specs are still changing. And it's still pretty early, but we want to build these higher level abstractions with everyone. So please look into considering like what kind of schemas you can implement, what kind of chains you can link to, what other kind of stuff are useful to add the DADs, and how we can link up all these services together. But that's all I have. So I'll stop sharing.
Cool. Thanks, Zach. And yeah, as Zach said, definitely come by our Discord. Let us know what you're working on. Let us know how you're using it and how it can be helpful. Happy hacking, everyone.